So here we have 9 questions, and let's go through one by one. The first one is compare the advantages and disadvantages of using SPI versus I2C serial communication protocol. I think this one is straightforward. I explained many times already, so I think you can try to list out what are the advantages and disadvantages of each of this communication protocol. I think no need to explain again. Yeah. Uh, Number 2, what are the limitation of the number of devices that can be connected to SPI, I2C, or UART bus? This one also uh, have been discussed many times. So, for example, SPI, what is the limitation of the number of devices? Of course, the limitation is the number of pin, right? Because you need it, uh, one line for each extra one line for each device. So, for example, if you have 40 or 30 I/O pin for your microcontroller, and you have already used 3 for data out, data in, and clock. 3 is a must, and if you have 30 uh, 30 30 I mean 30 IO pin, so you have 27 left for the uh, for the activation line alone, not including any IO device that you want to do. For example, you want to connect to other LED or LCD, right? So the limitation is there because you have the extra uh, ex- extra select chip select line. This one is depend on the address, so it is actually because we use address, so 7-bit you can have up to 2 power 7 devices, and UART is actually 1 to 1. So it depends on your microcontroller how many UART that you have. So this one I think is easy to answer. Now number 3. Number 3, you need to do a little bit calculation and try to do this. Uh, uh, SPI link is running with 100 kilohertz clock. So how long does it take for a single message containing 1 byte, 1 data byte, to be transmitted? Can you answer this? Anyone? Okay, very fast. Anyone can answer this? I think okay. I think we have the answer in the chat. Let's have a look at this. 16 microsecond, yeah, Divaka, is it 16 microsecond? Is it correct? Any other answer? Okay, thank you, Divaka. The answer is correct. Good. So, how to get 16? Uh, so remember, the SPI, 1 clock cycle represent 1 bit. Okay, so for the 1 byte data, so we will have 8 clock cycle, right? This is how many cycle? 4, 5, 6, 7, 8 for 1 byte data, right? So this is clock. So for data, 1 byte data here, and we have 100 kilohertz frequency. So one clock cycle represent 1 bit data. So here the duration of one clock cycle is, of course, 1 over 500k. So we have 2 microsecond for one cycle, and 1 byte means that we have 8 bit multiplied by 2 microsecond, so we have 16 microsecond for one data byte. So it's easy. Number 4, an embed configuration as SPI master is to be connected to 3 other embeds. It's configured as slave. Sketch the circuit showing how this interconnection could be made. Explain your sketch. So I think this is easy, so you can do this. Yeah. So you just refer back to the note. Number 5, an embed is to be set up as SPI master using pin 11, 12, and 13 running at frequency of 4 megahertz with 12-bit word length. The clock should be idle at logic 1 and data should be latched on its negative edge. Write the necessary code to set up this. Okay, number 5 is to write the code, but I want to skip this first because I think we have only another 10 minutes. So I want to do number 6. Yeah, this one maybe we discuss next week. You try to answer this first, but this one is related to number 3, but this one is for I to C to calculate the same thing, but uh, use I to C. So repeat question 3, but for I to C, ensuring that you calculate time for the complete message. All right. So here now we calculate already using SPI is exactly 16 microsecond. But what if we use I to C? So the I to C, remember, uh, the data that, that we send is not only the data. We need to send the address. We need to send uh, the read write bit. We have also the acknowledge bit. So we need to take that into account also. So let's look at the ideal case for the I to C at the SCL line. So when we have the data, of course, the first one will be the data. Sorry, the address, which is this is 7-bit address. So the first one we need to take into account is the address, which is 7-bit, and we have another one. This one is the read or write bit. So number 2 we need to take into account is read or write, which is 1 bit, and we need another one which is acknowledge. So the number 3 is acknowledge, which is 1 bit also, and this one is followed by the data, right? 8-bit data. This is address. 8-bit data, the data, So number 4, we have data, which is 8-bit. And we need to have the acknowledged. This is again acknowledged, and because 1 byte data only, so after that it stopped already. This is stop, so don't count. So we have another one, number 5, acknowledged is 1 bit, and that's it. So how the total, how many bit we need to send? Yeah, how many bit that we need to send for a 1 byte data? So this is a 18 bit, right? 18 bit, and of course 1 bit, because we use the same clock frequency. So 1 bit is 2 microsecond, and so the answer is 18 multiplied by 2, so 36 microsecond for the I to C. So we can see that for the I to C, the speed is slower than the SPI, right? That's why we can say that the advantage of the SPI is fast as compared to I to C, because to send, with the same clock frequency, to send a byte data, 1 byte data, the I to C need 36 microsecond, but the SPI only need 16 microsecond. Now let's see if we use UART. Yeah, so this one, number 9, use UART, but you change in your notes. I will share the note later, because there are some updates, right? Uh, Instead of 500 kilohertz, because the unit for UART is baud, so this is 500k baud, 500 kilo, 500,000 baud. This is equivalent to 500 kilohertz actually. So for UART, now let's see for UART to send 1 byte data. So let's say that we don't have parity bit. So in this case, so what we need to have is the start bit, which is 1 bit, and we have the 8-bit data. And for example, we don't want to use the parity, any array checking. So we have the stop bit here, and done. So to send 1 byte data for UART, you need to send 10 bit at a time, including the start bit and the stop bit. So it will take 10 bit multiplied by 2 microsecond, because 1 bit, the duration is 2 microsecond. So you need 20 microsecond in order to send a byte of data. And if you have parity bit, you need to have another one. So if you have parity bit, you have an extra before you stop, and now you have 11 bit, and you have 22 microsecond at least that you need to send byte of data. So in conclusion, we can see that the fastest one is this SPI, and then followed by the UART, and the slowest is of course the I2C, right? But again, this is when we compare the speed. So the advantage and disadvantage uh, is we need to look at different aspect. So we have learned, and we know that each of this protocol has unique advantages and disadvantages. So it depends, right, on the application that we want to use, whether we want to use it, which one, right? So that is for number 9. So 11 already. I think we are done with this, except that we have number 5, 6, 7, 8 to be answered. So you can try to do this first, and then maybe next week we can discuss this, right? So for today, I think it is done. Thank you, and see you next week.